Let us use the compression force theory to explain the formation of So this was propounded by a man called E. J. Whelan, and according to him, the East African Rift, the Earth crust, the Earth's crust was subjected to compression. E.J. Whelan uses compression to explain the Rift Valley Formation and Rift Valley lakes. Was subjected to compressional forces. These compressional forces were pulling, pushing into the center, and the continuous pushing resulted into formation of lines, lines of weaknesses, which you have called the fault lines. So, in this case, this was followed by the central block. It was followed by the central block overriding. Not the central block this time, the side blocks. Followed by the side blocks overriding the central block. And forming a rift valley. So this formation of the Rift Valley the continuous process of compression compression attacked the central what? It attacked the central block. After attacking the central block, a depression was formed. Forming what? A depression within the Rift Valley floor. Creating a small depression within a Rift Valley floor, and this was followed by the depression being filled with water, and to become what? A Rift Valley lake. This water is mainly rainwater, and preferably some other river and streams, bringing in water into the depression that is later filled with water to become a Rift Valley lake. So you can illustrate it here by saying before faulting This is what happened onto the Earth's crust. The Earth is crusty. That was before faulting, and that's how the Earth's crust was. That is before the Earth crust was. Before the Earth's crust was attacked. Before the Earth's crust was attacked. Then during the process, during faulting, compression forces were pushing into the center. Compression forces pushing into the center. These compression forces, and this led the formation of lines of weaknesses, followed by formation of lines of weaknesses, which we have termed as the faulty lines, creating three blocks, A, B, and C. So these are our faulty lines. And that's how the Earth crust looked during the process of faulting. And later on, after faulting, so this section of a sharp edge is removed by denudation processes, e.g. denudation processes like weathering, soil erosion, such that this sharp edge is removed, and then a depression is created, which is where after being created, a depression within a depression is formed to form a Rift Valley lake, which looks like that. So, that's the Rift Valley Lake. This is the compression, creating a depression within a depression. So that is the theory of compression. So this was propounded by the man called what? E.J. Whelan. To him, the Earth's crust was subjected to forces which were pushing into the center. These forces were pushing so hard that the result was the Earth crust starting to develop some lines of weaknesses that were called fault lines. And these fault lines were followed by the side blocks overriding. The side blocks had to override the central block. That's why you see, during faulting, this block A is rising. This is the extent of block A. Actually, this is our block A. Now, this was initially our block B, which is left under. Then this one is our block C. Block C. Block C and block A. Block A and block C went up, which we are calling overriding. They went up. They went up. This time they were at the same level. This is the level of the Earth's crust. But now they were pushed hardly into the sides by compression forces. So these ones went up, and the other side also went up. But block B, which was in the middle, remained stable in the same level it was initially. So after some time, this had it rise up and the other had it rise up, creating something that looks like that one. And later on, due to denudation processes, when I talk of denudation processes, I mean weathering took place or soil erosion took place, and this sharp edge was removed. This sharp edge was later on removed like that. And when it was removed, finally, the Rift Valley was formed, which looks like that. So, secondary faulting took place in the floor of the Rift Valley, creating a depression within a depression that was later filled with water to become a Rift Valley lake. So examples of those lakes, we have already named many of them. That's where we have lakes Albert Edward George, Tanganyika, Turkana, Malawi, Eyasi, Elementator, Naivasha, Magadi, and so many more others. These lakes are very many. They are the most common lakes in East Africa, and we look at them by how can we tell that these are fault lakes? By looking at their characteristics. Let us briefly look at the characteristics of these Rift Valley lakes. How can I know that these are Rift Valley lakes? characteristic of Rift Valley Lake is the first and foremost, they are long, narrow, and deep. Such lakes are very long and they are very narrow in size. They are not very large as opposed to downwarp lakes. These lakes, the Rift Valley lakes, are always very long. They cover several kilometers in length, but they are not very big. They are narrow usually and they are deep down. So that explains, or what is one of the characteristics of a Rift Valley lake. They are always long, narrow, and deep. So that's how you can tell us that these are Rift Valley lakes, by looking at how long they are, how narrow they are, and they are very deep. The other thing is, of course, they are found in the Rift Valley. They are found in a Rift Valley floor. Wherever they are, wherever you find them, get to know that these lakes are usually found in the floor of the Rift Valley, and they are salted. They are usually salted. Most of these lakes contain some salty elements. Take an instance of Lake Magadi is the best example. It's the best example of a Rift Valley lake that contains salt in it. So that is another characteristic that we can use to explain Rift Valley lakes. They contain salt in them and they are salted by nature. They are less covered by swamps. Since we have said they are deep, it gives no room for the growth of a lot of swamps, and so you will find that they are rarely muddy. They are rarely muddy because they are usually found deep, and the water rarely gets stagnant. So that is how we can explain these Rift Valley lakes. Most of the Rift Valley lakes in East Africa are formed by this process, as I've already explained it to you. Let us look at the type of lake number 2. Lakes due to downwarping. Lakes due to downwarping or downwarped lakes. In East Africa, downwarped lakes are mainly 3. In East Africa, we mainly have these 3 lakes: Lake Victoria, Lake Kyoga, and Lake Simia. Lakes Victoria, Kyoga, and Lake Wania. How are they formed? These lakes are formed when the Earth's crust was gently deformed. The Earth's crust was gently deformed downwards. The Earth's crust was gently deformed downwards, whereby the side blocks were upwarped. the side blocks were upwards, while the central block was gently downwards. Then after that downwarping, the central block, a depression in the center, was created. A depression in the center was created. So upwarping of the side blocks and then downwarping of the central blocks of the central blocks forced rivers that were flowing in the opposite direction to change their course of flow. So those rivers that were flowing in the eastwards, those rivers that were flowing eastwards and westwards were forced to change their course of flow and started pouring water. In the depression created. This led to this is later on to the filling of the depression with water to become what? A lake. So, those examples of rivers, that changed their flow, that changed their course, we have River Kagera. River Kagera was flowing westwards. River Katonga, Kafu, they all changed their course of flow, started pouring water into the depression created, filling it and becoming a lake. So, examples of such lakes. Examples of downward lakes in East Africa include, we mainly have Lake Victoria, which is always the biggest lake in East Africa, shared by all the 3 East African countries. We have Lake Kyoga in Uganda. And Lake Kwania. are some of the examples of downwarp lakes in East Africa. So that's how downwarping leads to the formation of a lake. Excuse me. Now, let us look at an illustration of downwarping. This is upwarped. This was the side blocks, upwarping of the side blocks. This one is now downwarping of the central block. So this is central block. Because of downwarping, rivers start to pour water into this central block. And this became a lake. This is our downwarped what? Our downwarped lake. Examples are Victoria, Kyoga, and Kwaniya. They all fall under downwarping. So we said that there are some rivers that were flowing eastwards and westwards, which were forced to reverse their flow of water and started pouring water into this depression. We have given examples of such rivers like river Kagera. Then rivers, Katonga. They all changed their nature of flow of river and started pouring water into the depression, including rainwater, filling the depression and becoming a Rift Valley. I mean, becoming a downwarped lake. They are by characteristics. These lakes are shallow and very wide. They are very shallow. That's one of the characteristics of these downward lakes. They are shallow. The water is not so much deep as compared to the other Rift Valley lake. Apart from shallow water, the water body is very wide. The water body is very big, covering several covers several what? Kilometers. Covering several what? Kilometers or square kilometers. Actually, covering several square kilometers. Covering several square kilometers. Then apart from that one, they are not very long, they are relatively short, they are shallow, they are made up, surrounded by, they are mainly surrounded by a very big swamp. Because of having shallow waters, they are usually surrounded by a very big swamp. So that is lakes due to downy, lakes due to downwarping. Let's look at lakes due to volcanicity. Lakes due to volcanicity. Sometimes we call them volcanic lakes. The volcanic lakes. So we know the process of volcanicity. By definition, let us briefly define what volcanicity is. We said it is the process by which molten materials are either ejected or injected onto the Earth's surface. That's how we define the volcanicity. Briefly, to give you a highlight on volcanicity before I go to volcanic lakes, we should note that volcanicity is the process by which molten materials are either ejected or injected onto the Earth's surface. Now, because of that, there are mainly two types of features that are formed as a result of volcanicity. They are those we call intrusive landforms. There are those we call intrusive volcanic landforms. So such intrusive volcanic landforms include a sill, a dike, we have a batholith, we have lapolith, we have lacolith, and very many other intrusive volcanic landforms. Our today's topic is not about volcanicity, but I want to bring you towards, I want to explain towards these lakes due to volcanicity. So after the intrusive volcanic landforms, we also have some extrusive volcanic landforms. So these extrusive volcanic landforms, that is where we have our lakes, the crater lakes, the calderas, and the lava dam lakes. Calderas, craters, and lava dam lakes. So, some lakes in East Africa were formed by caldera, were formed by volcanicity, and that is where we have our examples. The types of such lakes are mainly three lakes. To begin with are crater lakes. Number one, we have crater lakes. The crater lakes. Now, one of the features formed as a result of faulting is called a crater. A crater is a small depression or basin-like depression found on top of a volcanic mountain. So a crater is that small depression that is found on top of a volcanic mountain. Now it is formed. How is it formed? It is formed when volcanicity or formed when violent eruption. It is formed when violent eruption. Violent what? Eruption blows off the head. Blows off the head of a volcanic. Blows off the head of a volcanic what? Mountain. It is formed when violent eruption blows off the head of a volcanic mountain and creating a depression on top. Creating a depression on top. So this depression, of course, lava or magma solidifies within the vent. Lava or magma solidifies within vent. And by so doing, a depression that is sealed. A sealed depression. Sealed depression is left behind. A sealed depression is and later on filled with water. Filled with rain water. Later filled with rain water to become a rift valley, to become a crater lake. To become a crater lake. So in East Africa, examples of such crater lakes That's where we have our Lake Katwe in Uganda. Kitagata we have Ngorongoro crater. So those ones are crater lakes. So let us look at an illustration of what I mean. So I've said that down here is called a vent. Then here is our crater lake. Then this is a volcanic mountain. A volcanic mountain. Actually, craters and calderas are alike. Craters and calderas are usually alike. The only difference is a caldera is bigger in size. It is caused when there is violent eruption blowing off the head of an already existing crater lake and deepening it and widening it, making it the depression increasingly bigger in size and also being filled with water to become a caldera. So calderas are very large craters. So let us briefly look at number 2, calderas. So how are calderas formed? Calderas, by definition, we have said these are what? Large craters. They are formed when violent eruption blows off the head of a crater. When violent eruption blows off the head of a crater on top of a volcanic mountain. Widening it and even making it more deeper. So this large depression created this very large depression created is filled with water to become a caldera. To become what? To become a caldera. So initially, as I've already told you, that calderas are formed. Primarily, the first thing to be formed is a crater. The crater lakes are primarily formed, but then later on, when after being formed, it so happens that under the Earth's surface, sometimes volcanistic comes, or volcanic materials, or magma, or molten materials come when they are fluid and mobile. Fluid and mobile and very viscous. Now that they come, when they are very viscous, they are violent. No, they come with a lot of pressure and they blow off the head of a volcanic mountain. They blow off the head of a volcanic mountain, creating a very deep and wide depression. That deep and wide depression is later filled with rainwater to become a caldera. So examples of calderas. The best one is Ngorongoro caldera. Ngorongoro caldera is the best example of a caldera. So the third type of volcanic lake. The third type of a volcanic lake is lava dammed lakes. Of course, during the process of volcanicity, molten materials blocks a river valley. As water is flowing in the river valley, water from the river flowing over a river valley, molten materials from the volcanic mountain may block that river valley, and after blocking the river valley, they make a very large heap of materials that later on solidify. Now, all the water that was flowing over that direction is forced to back upon behind these materials left behind by lava. So after backponding they create the once river ceases to exist and becomes the water floods, of course, because of blocking or because of the artificial wall that was created by lava, forces this water to stop flowing and become stagnant, spreading over a very wide area and becoming a lake. So example of such is Lake Mutanda. Lake Mutanda and Mulehe are usually lava dammed lakes. They are mainly formed because of lava damming. So we have said how are they formed. We have said that these are formed when lava or flowing lava, blocks a river valley, forcing water in a river to stop flowing. And back upon this or spreads over a wider area, now creating a lake. So some of the examples of such lakes: lakes that were formed by lava damming, we have said include what? They include the Lake Mutanda and Lake Mulehe. These are found in southwestern Uganda. So those are the three types of lakes due to volcanicity. The first one was a crater lake, the second is a caldera, now the third is a lava dammed lake. So far those are three types of lakes we have seen. The first one was a volcanic lake or lakes due to volcanicity. Then the second one was fault lakes, and the third is a downward lake. Now let us look at the other type of lakes. Let's look at lakes due to glaciation. What we call glacial lakes. The best example of a glacial lake we are going to talk about are Italis or Coris. These are small depressions found in glaciated mountains. These depressions are formed when they are formed when rainwater enters into the cracks. Enters where? Into the cracks on the sides of a glaciated mountain. Now this rainwater, because of very cold condition, solidifies. This rainwater solidifies. That's one. After solidifying, becomes ice and exerts pressure. It exerts pressure on the cracks. So after that, these cracks are later on they widen and deepen. They widen and deepen. So later on, rainwater, after when the temperatures increase, of course, when temperatures increase, the once ice melts. The once ice melts and collects into the widened cracks. So the process continues. The process continues until the cracks are widened to become small depressions. Until the cracks are widened to become small depressions known as tunnels. Or cories or sakis. Known as tunnels, cories or sakis. And in East Africa, the best examples of such, we have Teleki in Kenya, Teleki Mount on Mount Kenya in Kenya. We have Lake Dunaya Lake Du Speak and Lake Du Catherine. These are found on Mount Rwenzori. In Uganda. So that's how terns or corals are formed. First and foremost, the corals or terns are very small depressions, very small lakes that are found on the sides of glaciated mountain. Now, these depressions are formed when rainwater enters into the cracks that exist on the sides of a glaciated mountain. Now, after rainwater has entered into these cracks, during the night the temperatures fall and they fall below freezing point, and the once water solidifies to become ice. Now, the ice that is created exerts a lot of pressure. We are told that it exerts more than 10% pressure onto the cracks that were created. So continuous pressure to the cracks forces the rocks on the sides to shatter through what we call frosty shattering. Now, after shattering or breaking, they are widened and deepened. The process continues until cracks are widened and a small depression that we usually refer to as terns or corals are created. Now, these sakis, corals, or whatsoever, they are filled with water, especially rainwater, to become small lakes. Such lakes, we can find them on Mount Kenya in Kenya, Mount Rwenzori, or Mount Kilimanjaro, the only 3 mountains in East Africa that have ice on their tops. In most cases, these lakes are usually used for tourism. They are mainly used for tourism. So those are lakes due to glaciation. And that is the 4th type of lakes. Other types of lakes, let us look at lakes due to deposition, what we refer to as depositional lakes. Lakes due to deposition. Let's look at depositional lakes. Or lakes due to deposition. That's where we're going to have our first type of lake called the lagoon lakes. So lagoon lakes are lakes that are formed because of wave deposition. Usually, whenever there is along a lake, say for example Lake Victoria, wave deposition brings about development of what we call sandbars. Sandbars spits and sandbars. Now, as the wave is coming onto the coast, it deposits materials along the coast here. These materials are made up of sand and pebbles. I may be shell. Now they grow, these materials grow until when they block some water. Until when they block some water inside here. And this is mainland, this is our lake. Now, this land that has been created, this water that has been blocked off here forms a lagoon. So the best example is Nabugabo Lake. Nabugabo Lake, that was cut off from Lake Victoria. It's the best example of a lagoon lake. So by description we shall say that lagoon lakes, these are formed when the positional materials by wave action creates a ridge like mold of materials, a ridge like mold of materials that seal off part of the water, body. Surrounded by a sandy bar, surrounded by a sandy bar of papyrus, rock boulders, and other depositional materials. And the other depositional materials. Now, the water in between the mainland and the sandy bar is referred to as referred to as a lagoon, lake. So this is how Lake Nabugabo was formed. That's how Lake Nabugabo was formed. It was formed when a sand bar separated the landmass from Lake Victoria. So that's how it looks like. So that one is known as a lagoon. Clear? That's clear. So the explanation comes first, then the diagram comes later. Begin from the explanation. These are formed when depositional materials by way of action creates a ridge-like mold of materials that seal off part of the water body, surrounded by a sandy bar of papyrus, rock boulders, soil, sand, and etc. So, and other depositional materials. So, the water in between the mainland and the sandy bar is referred to as a lagoon lake. This explains how Lake Nabugabo was formed. So briefly, Lake Nabugabo is a lagoon lake. It is found on the shores of Lake Victoria. Clear? Then after that, we can look at an Oxbow Lake. Look at Oxbow Lakes. So Oxbow Lakes are usually found in the lower course of a river valley. In the lower course of a river, in the lower course of a river valley. They are formed when river meanders, when depositional materials, they are formed when depositional materials, blocks, or cuts off a river meander. Forcing the subsequent river to divert its course and water back upon this water, of course, back upon this behind these depositional materials. Backer ponds behind these depositional materials. To create what? A lake. Such cases have been seen along such examples of lakes have been seen along where? Along river Nzoia. They have been seen along river Nzoia, Tana, and Rufiji. That's where we have some of the Expo lakes. By illustration, it will look like this. Now, as the river enters into the old stage, it begins to make such bends. So, deposition starts to take place here. And later on, when deposition starts to take place, the river meander is cut off completely. The river meander is cut off completely, and the river now begins to flow straight. So as we are saying that this river is flowing, say for example, southwards. So as it is flowing, deposition starts taking place around here. Depositional materials takes place around the concave bend of the river, and finally you find that the bend has been cut off, the meander has been cut off. So deposition continues here. As deposition continues, the water which was flowing southwards is blocked off from here. It is blocked off from here. So the water which was flowing towards this side begins to flow direct. Begins to flow direct here, like this, because the depositional materials have closed off, have sealed off this river. So, but there was some water which was flowing like this. This water flowing continues, and back upon this behind here. It back upon this behind it here, and after back ponding, it creates an ox. Something which looks like this is created. Something which looks like that one is created. And this is called an oxbow lake. An oxbow lake. So that is lake due to, that was lake due to depositional lakes. We have looked at 2 of them. But now, we can look at another type of lake. Another type of lake we are going to talk about is called man-made lakes. Did you know that in because of various man's activities, lakes have been formed? There are some lakes that have been formed because of man's activities onto the earth crust. The man-made lakes. Man-made lakes are made during that period. They are lakes formed when man dig large holes onto the earth's crust. For example, through bricklaying, large holes, large pits, have been left behind. And we are told that partly this explains how Kabaka's lake was formed. How Kabaka's lake and Mata's lake Mata's lakes in Uganda were formed. So we are told that these pits are filled with water. These pits are filled with water to become lakes. Still, man has blocked some rivers some river systems have been blocked by artificial barriers. By artificial barriers. Sometimes we call it damming. Damming of rivers. Damming of rivers also leads to the creation of led to the creation of lakes. Since water back ponds behind the dams. The best example is Lake Kibimba was formed by this process. Lake Kibimba was formed by that process of lava damming. I mean, formed by that process of putting a dam on a river. So briefly, that's what those are the types of rivers and how they were formed. That's how various rivers in East Africa were formed, and that is how we group them. We group them depending on either the others are depositional lakes, others are man-made lakes. I've given you example of man-made lakes. We have Kabaka's Lake and Mata's Lake together with Kibimba Lake. All these lakes are formed by lava, by man. Now that puts us to an end. It puts us to an end. The importance of lakes to man. The first importance of lake to man is they contain they are used as fishing grounds. They are used as fishing grounds. That's one of the importance. Creating large quantities of fish that are consumed. Creating large quantities of fish that are consumed. For example, large quantities, we have large quantities of tilapia and Nile perch. Large quantities of tilapia and Nile perch in Lake Victoria and Lake Albert. That's one. So two, they are natural boundaries. Some lakes are natural boundaries between countries. The best example of Lake Albert is a natural boundary between Lake it's a natural boundary between Uganda and DRC. So it acts as a natural boundary. Number 3, they are habitats. Of aquatic animals. So most of the lakes, or not all actually, most, but all lakes are habitats for aquatic animals. Such animals include crocodiles, the fish, the hippos, etc. All live where? They live in water bodies. For example, Lake Kyoga. Another importance of the lakes, they aid in rainfall formation. They modify the climate of East Africa. They modify the climate of East Africa. How? Of course, through the process of transpiration, evaporation. The process of evaporation. They do what? They release moisture into the atmosphere form clouds and bring rainfall. So that's one of the importance. They modify the climate. Of course, when these water bodies are heated up, they evaporate, they release excessive water into the atmosphere. This excessive water released into the atmosphere goes into what we call condensation level. Beyond the condensation level, they form clouds, especially the nimbus type of clouds that are associated with a lot of rainfall, and it is one of the ways of modifying the climate. And actually, this explains why most of the areas around the lakes are associated with a lot of rainfall. They are associated with a lot of rainfall. Especially which type of rainfall? The convectional rainfall. So that is another importance of lakes. In this case, lakes of East Africa modify the climate. They modify the climate. They contain water used for domestic purposes. Used for both domestic purposes like washing utensils, drinking, and also for industrial purposes. And also industrial purposes. For instance, for example, they are used as raw material. Water is used, water from these lakes. Water from these lakes are used as a raw material, in the breweries industry and the soft drinks industry. So the other thing is they are used as recreational grounds. Used as recreational grounds. For instance, some lakes contain beaches. Some lakes in East Africa do contain what? Beaches. They contain beaches. For example of such beaches, we have Lutembe Beach, Gaba Beach, mainly for revelers. So that is one of the other importance. The other importance is these lakes contain what? They contain minerals. Some lakes contain minerals that aid what? The mining industry. For instance, Lake Magadi in Kenya is well known for soda ash mineral. contains a mineral known as what? Soda ash. Soda ash. Very important for the making of fertilizers, and what? And glasses. So that is another importance. So apart from those ones, we can also include some negative importances, and then we call it a day. In summary, some negative importances we have: they are habitat for dangerous aquatic animals, they are habitat for dangerous aquatic animals. Like crocodiles are a very great danger to human beings. Then they occupy a large land. That could have been used for agriculture and settlement. So you can include more others at your own time, but for now, let us end here. Nice day.